Moving on. Now we're going to model how energy flows in an ecosystem, and there's a couple different ways we can do that. Some of these ways I guarantee you've seen before. For example, a food chain. A food chain shows one possible path for energy to flow through an ecosystem. Now, probably the biggest misconception that I encounter with students is the direction the arrows point. Okay, and what I mean by that is the arrows point in the direction of energy flow, because remember, this model is representing the path of energy. So we want the arrows to point in the direction of where the energy is going. The arrows do not point in the direction of what eats what. So for example, let me show you. Here's our food chain. The grass is pointing to the grasshopper because the energy from the grass will go into the grasshopper when it consumes the grass. Okay, we're not pointing the arrow the other direction saying the grasshopper eats the grass. So make sure that makes very clear sense. And this is again just one possible food chain, one possible path of energy flow for this given ecosystem. Now, obviously, in most ecosystems, there are multiple food chains happening at any given moment, sometimes overlapping, and those we kind of have developed another model called a food web to best represent all the paths of the food chain. So a diagram of all the different possible food chains, like so, would be called a food web. Now, most species have evolved to eat more than one food source, right? That's a really good adaptation because if one food source disappears, you will still have other options for things to eat, okay? Also, the more different food sources you rely on, the more stable your population will likely be. So here's just one example of a food web. The last model that we sometimes use to show energy flow through an ecosystem is an energy pyramid. Okay, the usefulness of an energy pyramid is that it shows how energy flows, and it also shows the relative amount of energy for producers and all the subsequent consumers. So I'll show you what I mean by that in just a second. Let's get this definition down first. So here's one example of an energy pyramid. As you can see, we have our producers at the bottom. So we have our phytoplankton, our seagrass, and our algae. We have our first level, or sometimes we call them primary consumers. These are things that feed on our producers. Okay, remember, these would also be described as herbivores because they are eating producers or plants. Then we have a step up from that, these fish that feed on our primary consumers. So these would be called secondary consumers. And then lastly, we have our tertiary consumers. And typically, as you go up the food pyramid or the energy pyramid, the organisms tend to get larger in size, okay? Now, if you notice too, this actually has the amounts, okay, of biomass in pounds. And the take-home point I want you to get from this is we don't tend to think of sharks as needing a lot of plankton because they don't directly feed on the plankton. However, what this is kind of showing you is to support one gray reef shark, we need up to 1,000 pounds of primary producers, okay? Just to support one shark, because remember, that's supporting all the steps below the shark. This idea of one level, affecting levels that are much further up, or one level affecting levels that are much further down, is going to be really important for tomorrow when we talk about something called a trophic cascade. And we're going to be talking about the gray wolves of Yellowstone, which was a real life situation of a trophic cascade that I find to be absolutely fascinating. So we'll be watching a little video clip on that tomorrow. Okay. Now I'm going to need you to make your own energy pyramid diagram. I'm sorry that got cut off. It should say energy pyramid. I would do this on a full page of notes, like one entire page, because there's going to be a lot that we're going to label. And on this large page, I want you to first make a triangle. And I want you to divide it into 4 separate sections like so. Now, the bottom of our triangle, we're going to label as producers. It's up to you whether or not you want to draw a picture. If you don't, that's perfectly fine. Just make sure you have it labeled as producers. I'm going to add in some grass for my producer. My step above that, I have my primary consumers. Remember, these would be our herbivores. And for this situation, I'm going to use grasshoppers as my primary consumers. Step above that, we have our secondary consumers. Our secondary consumers could either be omnivores or carnivores, really. Those are going to be my frogs. And my tertiary consumer at the top is going to be a hawk. All of these different levels of my energy pyramid are called trophic levels. Okay, trophic comes from the word energy, so energy levels, which makes sense. So please make sure you label trophic levels because that's a vocabulary term you're going to need to know. And again, we're just showing the energy flow from one trophic level to another. One rule that we associate with trophic levels is what we call the 10% rule. And that is describing the relationship of between each level. Only about 10% of the energy at each trophic level moves up to the next level. Okay? Now, what that means in terms of its impacts is that in order to support one hawk, we need a lot of grass, okay? And a lot of grasshoppers, because only 10% of that energy is going to go up to the next level. So please make sure you write 10% level in your notes somewhere off to the side. And again, we could think of the amounts as either being like the energy pyramid I showed you previous, actual pounds of biomass, or we could think of it in terms of calories, okay? So if we had 10,000 kcals of energy at the base of our pyramid, that's only going to provide 10 kcals of energy to the tertiary consumers. You don't have to label that. I just wanted to kind of add that additional information. But everything you see on the screen now is what I need you to please have in your notes. Okay, so our take-home points for today. Number one, there's a reason we're going through all of this information. In order to, again, describe those complex ecological relationships, we also need to know not just how life is organized, but how energy flows from one group to another in a given ecosystem. Also, be sure to complete the homework on this lesson and submit it to me through Schoology by 9 a.m. on Friday, March 20th. And